All right, so we're going to solve higher degree equations, and we're going to use some things from previous sections, such as conjugate pairs. We talked about that some. We're going to talk about zeros and linear factors. We'll kind of review the methods to solve quadratic equations, and then we actually get right into solving a couple of higher degree equations. Okay, we'll solve a third degree equation and a fourth degree equation. All right, I'm going to go to the application screen. Okay, I'm going to go on the lecture notes. I'm going to pull up the 3.7 lecture notes. All right, so as far as the book is concerned, it's topics, theory of polynomials, polynomial functions, the second half. Okay, but in layman's terms, we're basically solving higher degree equations. All right, and there's really only one slide, and it's the conjugate zero theorem. And what it basically says that, and what we talked about previously, is that all conjugate, or excuse me, all complex numbers, right, and the standard form of a complex number is a plus bi, it must have a conjugate zero. The conjugate zero for a plus bi is a minus bi. In this section, you'll basically be given zeros, and you'll be asked to find the other zeros. Now, we talked about what the physical representation of a zero is. It's actually x-intercept. We talked about imaginary roots or imaginary zeros. Those are actually, they don't touch the x-axis. Right? We talked about real zeros, and real zeros actually touch the x-axis. So I'm going to go back to our document camera, and I'm going to write out some examples of what are called conjugate pairs. So if you're given one complex number as a zero, just keep in mind that it must contain a conjugate pair. And so here are the conjugate pairs. In one column, I'm simply going to list the complex number, and then in another next column, we'll list out its conjugate pair. So we have 3 plus 4i. Negative 2 minus 2i. Okay, so I have this complex number 3 plus 4i. Well, what's its conjugate pair? Well, for the conjugate pair, we simply change the sign of the imaginary term. So the conjugate for 3 plus 4i would be 3 minus 4i. The conjugate for 3i would be negative 3i. Now keep in mind 3i, if you write that out in standard form, it can actually be written as 0 plus 3i. So here again, the fact remains that for the conjugate pair, you simply change the sign of your imaginary unit only. And then for this last example, negative 2 minus 2i, its conjugate would be negative 2 plus 2i. All right, so we leave the sign of the real part alone. We simply change the sign of the imaginary unit. All right, so those are conjugate pairs. Next, we'll review the zero and the linear factor relationship. So we can actually rewrite zeros as linear factors and vice versa. We can write linear factors as zeros. So theoretically, our zero is c, the value c. To write the zero c as a linear factor, we would write that as x minus c. All right, so here's some examples. If we have a 0 or 2, we can write 2 as a linear factor. So if I go back up to my formula, I can substitute c for 2. So if c is 2, I can write out my linear factor as x minus 2. So 2 is a 0 is x minus 2 as a linear factor. All right, so from a previous class, notice that if I were to set this equal to 0 and solve for x, I would in fact get my 0. Right? Let's say negative 2 is a 0. Well, if I were to substitute 2 for c, a negative times a negative is a positive, so I would actually write the 0 of negative 2 as x plus 2 as a linear factor. So let's say if I had the 0, 3i, to write 3i as a linear factor, I would substitute 3 for c, and I would write that out as a linear factor as x minus 3. And then lastly, notice that all complex numbers come in conjugate form. So the conjugate of 3i is negative 3i. And if we were to write negative 3i as a linear factor, we would write that out as x plus 3i. Right. So you may say, well, why is something like this important? Well, keep in mind that a 0 is nothing more than the x-intercept. Right. So here is an example. All right, and I'm gonna open up my shared screen. Okay, for whatever reason, it's like one of those. Okay, I actually want to do problem number 4 and number 6. I want to start with problem number 4. Well, I guess before I start problem number 4, let me just give a simple example before we actually jump off the deep end. Let's say that I am given, and this is just an example, I'm given the zeros 2 and -2. I want to find the equations, or find the equation. And I'm just going to sort of word it like this. All right, I'm given 2 zeros, +2 and -2, and I'm asked to find the equation that gives me these 2 zeros. The first thing I'm going to do is I'm going to kind of draw out a physical representation of this. So I have an X and a Y axis. 1, 2, 3, 4, 5. Right. So we talked about something that was called the nth degree theorem, and it says that if I'm dealing with a polynomial, that polynomial has up to but not exceeding the number of zeros as its power. For example, here I have 2 zeros, which would give me a square. So this could possibly be a quadratic equation. If I were given 3 zeros, I would be able to write out a cubic equation. If I'm given 4 rows, I have a 4th degree equation, so on and so forth. All right, so since there's only 2 zeros, then this must be a quadratic equation. So keep in mind that a 0 is an x-intercept. So I'm going to plot these things on a graph. So I have -2 as a 0, and I have +2 as a 0. All right, so that means that when I were to if I graph my function, it should hit the x-axis at +2 and -2. But what is the equation that produces zeros of -2 or +2? In order to determine that, I want to write these zeros as linear factors, right? We're going to multiply those linear factors together, and that would give us our equation. So, for example, if I go back, we sort of written out 2 and -2 as linear factors. So 2 as a linear factor is x minus 2. -2 as a linear factor is x plus 2. To write out my equation, I can simply multiply these two things together. So I can use a FOIL method, right, or the distributive method. So I'm going to multiply everything in that second set of parentheses by x. So x times x is x squared. X times 2 is 2x. I want to multiply everything by -2. So negative 2 times x is negative 2x. A negative times a positive is a negative. 2 times 2 is 4. And then once I simplify, my two x values cancel, so I have x squared plus 4. Excuse me, I have x squared minus 4. And that should be a minus. So if I were to graph, that would be my graph. So notice I have two solutions. We took those solutions or zeros, we wrote them out as linear factors. We multiplied the linear factors, and that gave us an equation. Okay. All right, we also talked about long division and synthetic division. Okay, we use long division and synthetic division. You just want to make sure that your divisor and your dividend are in descending order. All right, so I believe we have enough in our tool bag to solve some problems. Okay, so now the first problem I'm going to look at is number 4. And the second problem we'll look at is number 6. All right, so keep in mind these two problems, you may see, or not may, you will see problems similar to these on your exam next Thursday. All right, so here we're given a problem and it says for the polynomial x cubed minus 10x squared plus 37x minus 4. All right, we're given a cubic equation. We're given 4 as one of the zeros, and we're asked to find the remaining zeros. So I'm going to go back to the document camera, and we're going to solve it. So this is 3.7, number 4, for the polynomial p of x equal to x cubed minus 10x squared plus 37x minus 52. 4 is 1 0, and we're asked to find all remaining zeros. So again, that polynomial is x cubed minus 10x squared plus 37x minus 52. Just double checking that. All right, so what do we do? Well, first off, it's a cubic equation. We're given 1 0, so there has to be 2 more zeros. All right, because of that nth degree theorem. Right? So how do we find the other 2 zeros? Well, I'm given one of the zeros is 4, and I'm given an equation. So here's the process. We can use synthetic division, and we can divide the two, right? I can use 4 as my divisor. I can use the P of X as my dividend. Once I divide the two, what will result is a quadratic equation, right? Because once we use synthetic division, that would lower our power by 1. So we can lower this to a quadratic equation. We could solve the quadratic equation, right? There's 3 methods you can use to solve a quadratic equation. You can use the square root property, you can factor, use the zero factor property, or you could use the quadratic formula. All right, so that's our process for this problem. We're going to use synthetic division, and then we're going to solve the resulting quadratic, and that will give us our 2 solutions. All right, so the first thing we're going to do is divide. Right, and we're going to divide x cubed minus 10x squared plus 37x 52 by 4, and we're going to use synthetic division. All right. So 4 is our divisor. Right. Remember that for synthetic division, you must have a 0. In this case, they gave us the 0, which is 4. Our dividend, once again, has to be in descending order. So in order to check that, I'm going to check the degree of each term. So here I have a 3rd degree term, a 2nd degree term, a 1st degree term, and then a degree of any constant is 0. Right, so I don't have to add any filler terms. So next I'm going to list out the coefficients. So 1 is the coefficient of my cubic term. Negative 10 is the coefficient of 2nd degree term. So notice I'm keeping my sign. 37 is the coefficient of my 1st degree term, and negative 52. So remember, the basic setup for synthetic division is that our first number always comes down and we add. All right, so now we're going to do our crisscross pattern of multiplying and adding. So 4 times 1 is 4. And I'm going to add up and down. So negative 10 plus 4 is negative 6. 4 times negative 6 is negative 24. 37 plus a negative 24 is 13. 4 times 13 is 52. And we have a remainder of 0. Now we should always have a remainder of 0 if you're given a 0. All right, so this is what's left. So keep in mind that these are coefficients for our equation. So we started out with a 3rd degree equation. Once we use synthetic division, our powers are lowered by 1. So this would be the coefficient of our squared term. So we have x squared. This would be the coefficient of our 1st degree term. This is the coefficient of our constant. Right? So we have equation x squared minus 6x plus 13. Right? So before we continue, any questions on this equation? Right? We use synthetic division. We divided. We lowered our degree of our dividend by 1. Now we're going to solve it. Right? So how do we solve it? We're going to set it equal to 0. So this is actually step 2, is to solve the resulting quadratic equation. All right. So whatever our equation is, we're going to set that equal to 0 and solve it. So now we're dealing with a quadratic equation. Right? So whenever you're solving a quadratic equation, your first thought is to see if you can factor it. Right? Are there two numbers so that when we multiply them, we get a 13, and when we add or subtract those numbers, we get a -6. Right? Well, now we can actually factor this. The only factors 13 are 1 and 13, and when we add or subtract those, we definitely don't get 6. Right, so that does not mean it can't be solved. What that means is we must use another method. The other method we're going to use is the quadratic equation. All right, so we're going to solve the resulting quadratic equation by using the quadratic formula. Right. So the quadratic formula, I'm going to just write that out. X is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. So now what we need to do is we need to pull out a, b, and c, substitute that in the formula, and that will give us the values for our two zeros. Right? Well, what is a, b, and c? Well, a is the coefficient of your secondary term, so a is going to equal to 1. B is the coefficient of your middle term. Okay, so I'm taking my sign as well as my number. So B is -6. And C is equal to 13. So I'm going to write this out as, right, there was a negative in the quadratic formula. B is -6, so I must make sure I substitute B as a -6. Plus or minus the square root of B squared, so B is -6, minus 4 times A, which is 1, times C, which is 13, all over 2 times A, which is 1. All right, so now I'm going to simplify. Well, this is equal to a negative times a negative is a positive. I'm going to bring down my plus or minus, very important because that separates out our two answers. So within the square root, I'm using the order operations that please excuse my dear Aunt Sally. All right, so first I'm going to evaluate my exponent. So -6 squared is 36. And then I'm going to multiply. Right, -4 times 1 is -4. -4 times 13 is -52. All over 2. Right, so now I can simplify my radical. So this is 6 plus or minus the square root of -16 over 2. Right, because 36 minus 52 is -16. The next thing I want to do is simplify this negative radical, so I'm going to rewrite the square root of 16 as 4i. So just to show that over here, the square root of -16, that's equal to the square root of -1 times the square root of 16. Right, the square root of -1 is I. The square root of 16 is 4. So the square root of -16 is 4i. All right, now from this point, to simplify, there's something called the divide by monomial theorem, and it says that if you have a plus b over c, then you can write that as a over c plus b over c. Right, which means that before I cancel anything, I want to rewrite this denominator as a denominator for every term in the numerator. So I'm going to write this out as 6 divided by 2 plus or minus 4i divided by 2, which gives us 3 plus or minus 2i. So my two solutions are 3 plus 2i and 3 minus 2i. All right, so for our cubic equation, it had one real root and then it had two imaginary roots. All right, any questions about that first problem? All right, so if I go back to the shared screen, and I believe it'll let you put in a plus or minus. Like 3 plus or minus 2i. All right, so any questions about number 4? You will see one similar to that again. All right, now let's check number 6. All right, so in problem number 6, we're given a polynomial and one of the zeros as in the last problem, and we're asked to find the remaining zeros. In this problem, we're given p of x is x to the fourth power plus 27x squared minus 324. Right. So notice that first off, we're dealing with a fourth degree equation, which means that we should have 4 zeros. And we're given that one of the zeros is 6i. Okay, so keep in mind that zeros come in conjugate pairs. So I'm going to go back to our document screen. Okay, and we're going to work this problem. All right, so this is 3.7, number 6. For the following polynomial, one zero is given. Find the remaining zeros. And we have that our function is x to the fourth plus 27x squared minus 324, and 6i is a 0. All right, so again, that's x to the fourth plus 27x squared minus 324, and we're given that 6i is a 0. Okay, so what is our process for this problem? Right, well, much sort of what we did in the last problem. We're given a 0, and we're given this polynomial function. The way we proceed to answer this problem is slightly different than the other problem, mainly because of the complex number as a 0. So what we're going to do in this instance, we know that we know that complex numbers come in conjugate pairs. So if 6i is a 0, then negative 6i has to be a 0. We will take those two zeros, convert to linear factors, we will multiply them together, and that would give us a quadratic equation. Then we're going to take that quadratic equation, we're going to equate by using long division. We're going to take the equation or the quotient, and we're going to solve it to find the remaining zeros. Okay, so there's a few steps to this problem. Okay, so this is the first thing we're going to do. We're going to write an equation from our two zeros. Write an equation for the two given zeros, right? Even though they gave us one, you know, 6i, it has a conjugate negative 6i, all right? So we have 6i, I'm gonna write that up here, 6i and negative 6i. If we were to write 6i as a linear factor, we would have x minus 6i. If we were to write negative 6i as a linear factor, we would have x plus 6i. All right, so here are my two zeros, and we're going to write out the quadratic equation that's formed. All right, so now if I distribute x times x is x squared, x times 6i is 6xi. I know that may look funny, but we can't actually multiply x and I because they're unknown, but we can write them out in a multiplicative form. Next, we'll distribute negative 6i. So negative 6i times x is negative 6xi. When we multiply negative 6i and positive 6i, a negative times a positive is a negative. 6 times 6 is 36. And I times I is I squared. Right, so now I want to simplify. All right, so I want to bring down x squared. The 6xi term cancels. I want to bring down my negative 36. And from our rules from complex numbers, I squared is actually negative 1. So when I simplify, I have x squared plus 36. So when I convert my two zeros to linear factors and I multiply, the equation that's formed is x squared plus 36. So now how does that help us? We can actually take this fourth degree equation and divide it by this second degree equation. So here is our second step. We're going to divide p of x. I'm trying not to be too technical here, but p of x is actually this equation. Divide p of x by the previous result, or the found equation. Okay, so just to write that out, we're going to take x to the fourth plus 27 x squared minus 324, and we're going to divide that by x squared plus 36. And we're going to use long division. All right. So remember that when we write out our divide and our dividend, it must be in descending order. So if I look at my divisor, I have my second degree term Let me use another sheet of paper. I have my second degree term. I don't have my first degree term, so I want to put in a filler 0. And I have my constant, which has a degree of 0. For my dividend, I have my fourth degree term. I don't have a third degree term, so I'm going to put in a filler third degree term. I have my second degree term, 27x squared. I do not have my first degree term, so I'm going to put in a filler x. And my constant or 0 degree term is 324. All right, so notice you got to be careful on this, and I put in some filler terms. All right, so now what is the next step? All right, well, I want to look at my first terms. I have an x squared and an x to the fourth. So what can I multiply my x squared by to get an x to the fourth? Right, and that would be x squared. X squared times x squared to the fourth. Where will I place my x squared? Well, since I have 3 terms in my divisor, I want to place the x squared above the third term in my dividend. Reason being is because I have to distribute. When I distribute, it's going to give me 3 terms. So we have x squared times x squared, which is x to the fourth. We have x squared times 0x, which is 0x cubed. Then we have x squared times 36, which is 36x squared. Now, one of the most important things to do is to change the sign. Right, so this term becomes negative. 0 is neither negative nor positive, but I will change the sign nonetheless. And this 36x squared becomes negative 36x squared. Right, so my x squareds cancel, my x cubes cancel. 27x squared minus 36x squared is negative 9x squared. So then I must bring down my 0x, right, because I have to maintain 3 terms. I have to bring down negative 324. All right, so we're concentrating on x squared and negative 9x squared. So what do we multiply x squared by to get a negative 9x squared? We would multiply by a negative 9. Right? And then I would distribute. Negative 9 times x squared is negative 9x squared. Negative 9 times 0x, a positive times a negative is a negative. Okay, I get 0x. Negative 9 times 36 is negative 324. So most important, we change the signs. And our remainder is 0. So sort of what we did in the last problem, we took this resulting equation, set it equal to 0, and we solved it. All right, so that will be our third step. We would set the quotient equal to 0 and solve. Right, so I'm going to take my quotient, which was x squared minus 9. I'm going to set that equal to 0. And there's a couple ways we can do this. We can actually factor it. Right, we can write x squared minus 9 is x plus 3 times x minus 3. I could also use the square root formula. Right, I could add 9 to both sides. So this puts it in proper form for the square root formula I've isolated from my square root. If I apply the formula, x is equal to plus or minus square root of 9. Square root of 3. So x is equal to positive 3 and negative 3. Right, so any questions about that example? All right, so if I go back to our application screen, right, the remaining zeros are, I believe you have to put in negative 6, positive 3, and negative 3. All right, so any questions about number 6? All right, any questions about any, well, I'm going to stop the recording at this